Hello, welcome to Forage Drops. This is a weekly series produced by me, Dr. Liliane Silva. I'm a postdoctoral fellow at Auburn University, and I work for Drs. Molenix and Dr. Gillett. Today, I'll be talking briefly about carbon sequestration on grasslands. So let's get started. So just a general overview. In the southern USA, forage livestock systems are based on perennial grasses. Mostly, the most planted ones are Bahia grass, Bermuda grass, and tall fescue. Over the last couple of decades, there's been increasing concern about environmental impacts of forage livestock systems, which have shifted research priorities to incorporate more sustainable practices in livestock forage systems. Legumes are an alternative to chemical nitrogen fertilizer. Options of legumes to be incorporated in forage systems include several perennial, annual, and biennial species. Some examples are rhizome peanut, alfalfa, and clovers. One of the major nutrient pools that we have on the forage system is plant litter. Plant litter is especially important in forage systems where there's minimal or no chemical fertilizer input. When we are talking about litter, we're talking about the senescent material that is deposited on soil surface, and over time, it is decomposed. In some regions, this has different names, but generally we refer to this as litter, not just for forage systems, but in other plant systems as well. Low litter nitrogen concentration is common to warm season grasses, and the low nitrogen that's input in the system makes the ratio between carbon and nitrogen on those systems should be low as well, which can lead to nutrient immobilization, which is just that the nutrients that are available on the soil, they will not be readily available for the plants until that carbon to nitrogen ratio is met to the range that it is better for that system. Generally, the incorporation of legumes into forage systems provides nitrogen through biological fixation, which then becomes available to grasses if they are planted in mixtures with legumes. This nitrogen input increases forage yield and quality, animal performance, and soil health. Also, grazing animals will help with nutrient recycling through excreta deposition on pastures. So, talking about carbon sequestration on grasslands, perennial grassland soils contain large carbon stores due to limited soil disturbance and continuous above and below ground plant biomass. So what does that mean? This means that on perennial grasslands, we generally do not do a lot of tillage, but also, especially the warm season grasses, they are high yielding species, forages that will produce high forage yield throughout the year, and some of that material will be senescing and being incorporated in the soil. For example, this picture here on the top left is a picture I took from a Bermuda grass system. This was around November, probably December, in Central Florida. So the original pictures is actually 2 4 inches in the soil profile, but here we're seeing approximately 2 inches of the soil profile. So this around this time, the Bermuda grass was red senescent in preparation to the fall and winter season. So what we see here is the reminder of that forage that was produced on late summer, and this is just being just senescent, and we can see some very small material just as being incorporated on this more superficial portion of the soil surface. And when we talk about below ground plant biomass, we are just talking about the root rhizome system for forages. So, for example, here on the bottom, on the left, we have just some samples that I collected using a similar to a soil probe, just a little bit larger. So here are several samples that were collected and has roots here, and generally to estimate how much soil, how much root root mass we have on a specific area, we wash these samples. So this is just to show a an amount of roots system root rhizome system that we had on a rhizoma peanut sample. And this is the area that I was talking about for the top left picture, just when was start to senesce. So this ability to sequester atmospheric carbon from atmosphere and store in the soil contributes to climate change. That's why we have been hearing more and more often about disability of grasslands. And generally, carbon sequestration is affected by fertilization and legume adoption due to greater biomass, just forage yield and quality of the material being deposited on those systems. And currently, there are several studies being, which the major focus is on better understand effects of management strategies on carbon accumulation, including on diversifying the species composition of those systems, but also on management practices. So, why is it important to better understand the effects of grazing managements, for example, which can be defined by grazing intensity and grazing frequency? On this slide, I will just show some pictures. So, when we are talking about how often and to what stubble we should graze, we are aiming to leave some the proper coverage of the soil to just avoid having major spaces that does not have coverage, and also leave enough residual leaf area behind so you give better chance possible for the plants to just rapidly regrow after they are either cut or grazing. And these responses of how often and to what stubble we cut or graze will also affect not only the profile that the root system will be able to achieve, but also the amount of root that plant will be able to form. So here we have a heavy grazing system compared to a moderate and a light grazing And ideally, we want to be on somewhat on the middle here. That would be the recommendation, just so you're still able to properly use that forage being produced, but also allow the plant to recover and restore reserves and also the root system after either cutting or grazing those systems. And also avoiding having several pads of soil without coverage will also help on deal with issues that just the animals walking around, they can potentially cause some plants to die and expose those areas. And we could have some issues on some areas depending of the slope and how exposed those areas will be. So we could potentially have further issues with soil loss on those regions. So through management, we can also try to better cover that to avoid issues. And we also look at nutrient distribution on this case because animals, if you have animals on the system, they will be grazing and they can return to the pastures up to 80% of the nutrients they consume. So through a proper grazing management, we can optimize the distribution of those nutrients, which will favor forage yield and quality, especially if you have a system, an extensive system that generally there's no input or there's just minimal chemical fertilizer input on those systems. So thank you so much for hearing this Forage Drops today. This is what I had for this week. Please, if you have any questions, my mail is here on the screen. Feel free to reach out to me. And I appreciate you taking the time to hear this video today. And please check out our YouTube page for more videos and also for next week's videos as well. Thank you so much.